Hi everyone, welcome to the video. Today we are going to solve number of paths in a matrix with k coins. In this question we are given a 2D matrix, okay, of n cross n order along with a value k which represents the value which need to find. How we will find? We'll start from the very first cell, okay, start from the very first cell and move to the bottom right corner to the end, okay, from top left to bottom right, okay, but we are going only to two paths. Either we can go right or down from the current value, okay. So from 1 you can either go to 2 or 4 and not 6. 6 is not possible, only right and bottom is possible. So at point, let's say 6, you can go only 5 and 2 and not 1, okay, not 4, not 2, not 3, not other thing, just right side and downward side, either of them. Okay, so start from top left, go to the top right, bottom right, calculate the values and see how many paths are possible in order to have cell values summing up to the value of k. Okay, so at the end we need to return the number of cell values, number of path which yield us the k value k. Okay, same as k, not less than, not right than, not more than. Okay, just exactly k. So see in example 1. If you start from 1, go to 2, okay, then go to 3, then 6, then okay, 1 2 3 sums up to 6, go down 5 6 5 11, 11 and go down 1 11 1 12, and this was our value to reach. Again, there's one more path. Start from 1, move right, go to 2, move down 6, 1 plus 2 3 plus 6 9. Again you have three values, you have to you have remaining sum is 3, go down 2, 9 plus 2 11, and go right, 11 plus 1 12. So these were the two paths using which you can get the value, okay. And similarly, for example 2, you do not have any such path. If you want to understand in a detailed manner what I'm doing in my approach in this question, I'm attaching a Medium article which I wrote moments ago in the description of this video. You can go there and understand each and every aspect of the approach which I'm using. So in the time complexity, you can see we are given order of n cube, because n cross n and k, you'll take it order of n cube, okay. So I will use dp. You can use recursion also, but I'm using python, so it may give us tl. That is why I'm using just dp, okay. 3d dp, remember that. So first of all, I will create a dp, okay, and initialize it with completely -1 for I range, k plus 1 for I range, n plus 1 for I range. Cool. So I created a dp of range n plus 1 into n plus 1 into k plus 1. Cool. And I've filled it entirely with dp, with -1, sorry. Okay. And at the end, I will also create a utility function, util, and I will have three values: the current row, current column, and the remaining sum. Remember that what it is: current row, current column, and remaining sum. Initially we have initially I'm giving k because we have zero sum. We start from the we have not started yet, so we have to reach entire k value, that is k is entirely our remaining value. Okay, now utility, current row, current column, remaining sum. Remember that what is I, j, and k: current row, current column, I is current row, j is current column, and k is the remaining sum. Okay, now if the current row is n minus 1, or current column is n minus 1, because they are of order, a matrix is of order n cross n, and remaining sum is same as current current matrix value, which means we have found a solution. If the current row is same as n minus 1, which means we have reached the bottom right. Okay, row is n minus 1, column is n minus 1, which means we have reached the bottom right, and the value of matrix of this cell, of this particular cell, is same as the remaining sum value. In that case, we have found a path. We will return 1. We will return 1. Cool. We have found a path. Again, this was a base condition. Again, one more base condition. If okay, if row is greater than equal to n, or column is greater than equal to n, or remaining sum is negative, either of this value, either. So there are two conditions in this particular single condition. Okay, either you have gone out of the bound, okay, you have reached out of the matrix, okay, matrix arr, or remaining sum is zero, which means you have achieved a sum which is more than, which is already more than the value of k, which is already more than the value of k, which means you do not need to have anything you do not need to calculate anything from now. You have already exceeded your expectation, your value of k. Okay, you have reached, okay, a point out of bound for the matrix, or the value you need to find, you need to calculate remaining sum is negative, which means there's no possibility of getting a value of value k. In that case, you will return 0 because there's no path, there's no possibility of path. Now, one more base condition or say memorization, if this particular value, if this particular value has already been calculated, which means, see, initially I initialize with -1, which means if there is -1, if dpijk is -1, which means this particular value is not calculated. Okay, but if it is not equal to -1, it is something anything other than -1, which means it has already been, you know, traveled with. This path has already been traveled. Okay, so return this particular dp cell value, because it is already calculated. There's no need to calculate it again and again. That is why we imply dp. Now, as I mentioned in the beginning of this video, we are only given with two paths: either go down I plus 1j, or go right I j plus 1. Okay, go down or go right. So if you're going down, if you're going down, I will use recursion. If you're going down, to row value will be appended by 1, and column will remain same, and remaining sum will be k minus arr ij. Arr ij is what? Cell value of this matrix, and subtract that from the remaining sum. Okay, if your remaining sum earlier was 5 and this particular cell value arr ij is 3, then we the next remaining sum, the next new remaining sum will become 5 minus 3, which is 2. Okay, that is what we are passing. Again, if you are not going, if you can't go down but you can go right, there's a path. Row will remain same, but the column will increase by 1, error ij, if the remaining sum. And at the end, now that you have calculated the value of downwards on or rightwards, okay, append this value, append this value to the dp, to the tp, the dp ijk, down plus right, down plus right, mistake. Okay, and at the end, now that you have reached the end of this utility function, just return the cell value, return the cell value ijk. Okay, so I will explain once again by the time I submit it. So we have created a three-dimensional DP of order n plus 1 into n plus 1 into k plus 1, created a utility function, okay, and passed three values: current row, current column, and the remaining sum. Remaining sum is k. Okay, current row, current column, and remaining sum. Now, if the current row is n minus 1, or current column is n minus 1, and alongside that the current cell value, the current cell value is same as the remaining sum, in that case we have found the solution, because we have reached, we can get the value of k, and at the same time we have reached the bottom right corner. In that case, return 1. If we are going out of bounds, return 0. Okay, if this particular value is already calculated, return this well. Okay, there's no need to calculate. What is wrong? Okay, so I will just pause video and just see what I'm doing wrong. Okay, so now I have found what I was doing wrong. I have to check both the conditions. These both conditions should meet. That is only when we will be certified that we have reached the bottom right. Okay, if both row and column is same as n minus 1. I was using or, if in that case it will yield us wrong solution. Let me submit it again and see. This should work this time. Still it's taking a long time. No, it's just working. It's just their compiler which is facing a lot of queue. So yeah, this is the correct solution. It passed all the test cases. So again, I will reiterate that if you want to get a more detailed insight of my approach, I have attached a Medium article link in the description of this video. You can go read it and you will get a better insight, more detailed understanding. So thank you. Have a nice day.